Hello everyone. In this video, we're going to be dealing with trigonometric expressions. We have tangent 27 degrees equals x, and we're supposed to find the tangent of 6 degrees in terms of x, kind of like a function of x. Make sense? Obviously, you can find numerical values, maybe, right? But that's not the goal. We're going to find it in terms of x. So we want to find a relationship between the 27 degrees and 6 degrees. I'm not going to be writing the degree symbols all the time because that's kind of like, I don't know, I find it annoying and hopefully it's understood. But just letting you know. Okay, so even though I don't write it, it's always in degrees. So how do we solve these kinds of equations? We start with the given and then we try to build our way to the other angle. But first of all, before we get into the solution, I'm curious, do you think Wolfram Alpha can solve this problem? My prompt was something like find tangent 6 if tangent 27 is equal to x, of course in degrees. Or I said something like in terms of x, couple different trials, and this is what I got. Solution is x equals tangent 27. Duh, we already knew that. So unfortunately, Wolfram Alpha failed to solve this problem, which we're going to solve together. Okay, so again, tangent 27 is equal to x. Again, they're in degrees. And tangent 6 we're supposed to find. How do you do that? Here's how we usually do it. You start with 27 and then add some special angles to it, such as 27 plus 30, 27 plus 45, 27 plus 60, and try to get the 6. Or if this doesn't work, then you can try doubling the angle, tripling the angle, quadrupling the angle, some multiple of this angle. Hopefully will get us closer to 6. In this case, it is doubling. You know why? If you double 27, going back to arithmetic class, you get 54, right? 54 degrees. Awesome. What's the relationship between 6 and 54? You might be questioning. And the answer is their sum is 60. In some cases, it's the sum, in some cases, in some others, it is the difference. Okay? Ready? So in other words, I can write the 6 as 2 times 27 minus 60. Uh-oh, that didn't work, or that's negative 6. Or I can do the following, 60 minus 2 times 27, exactly. Okay, not very good at arithmetic, but that's the idea. Okay, cool. So let's go ahead and do this then. Start with 27, and then use the double angle formula, and then go to 6 from there. So tangent to theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. Hopefully you know this from tangent x plus y, replace x and y with theta, and you get the double angle formula. Now I want to replace theta with 27, and that gives me tangent 54 equals 2 tangent 27 divided by 1 minus tangent squared 27. Now, tangent 27 is known to be x, so this is going to be 2x over 1 minus x squared. Awesome. So I got tangent 54, but how am I going to go to 6 from here? Remember, 54 and 6 add up to 60. And 60 is a special angle. Do you know tangent 60? I hope you do. But if not, then I'll remind you. I'll help you remember square root of 3. Okay? Awesome. And you can find it in an equilateral triangle, split in half, so on and so forth. So now we're going to use this, but let's see how we can go to tangent 6 from 54. Obviously, 6 can be written as 60 minus 54, as we talked about it, right? And this is equal to, from the difference formula, remember tangent alpha minus beta is tangent alpha minus tangent beta. So this is my alpha, this is my beta, divided by 1 plus tangent alpha times tangent beta. Awesome. And this is equal to tangent 6. And this is what I'm looking for. And this is supposed to be in terms of x. Can we do it? Let's get to work. We know tangent 60 is root 3. And tangent 54 we just found in terms of x. Let's go ahead and do the replacements and simplify and see what we get. So tangent 6 from here is going to equal tangent 60, which is root 3, minus tangent 54. I'm going to go ahead and cheat here. 2x over 1 minus x squared. Once you find the numerator, the denominator is easy because all you have to do is multiply those two things, square root of 3 times 2x over 1 minus x squared. And guess what? This is the answer. Case closed? No. We still have to simplify it, so a little bit more work, but the rest is easy. Okay? Let's go ahead and make a common denominator, or you can just multiply the top and the bottom by 1 minus x squared, which is the same thing, but when you distribute, it's going to be a little easier. You're not going to have to deal with common denominators anymore. When I distribute this over root 3, I get root 3 times 1 minus x squared. When I distribute here, the 1 minus x squared is going to cancel out, and I'm going to end up with minus 2x. You see how easy that is? Divided by, when I distribute it over 1, it's going to give me 1 minus x squared. And when I distribute here, 1 minus x squared is going to cancel out. Try to visualize that. And you're going to get 2 root 3x with a plus sign, right? Good. That was easy. Now we can arrange these terms a little bit, simplify. So let's do the work. Here, if you distribute and write this in standard form, you're going to get negative root 3x squared minus 2x plus root 3. So that's a quadratic divided by another quadratic. And that's going to be negative x squared plus 2 root 3x plus 1. Notice how the coefficients are moving around, the root 3, the 2 root 3, the 1, so on and so forth. But this is basically the tangent 6 in terms of tangent 27. Obviously, you can do this differently and find the value of 6 using a different method, but this is what I was targeting. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.